the idea I just came up with was I was looking at a Slack that we were both in, and I was just seeing people type messages to each other, and then I was just seeing the faces of the people, and I was just thinking, wouldn't it be better maybe if instead of seeing them type, you could like see them talk, right? And then it's like, well, who wants to be on a video call with everyone all the time? That would be a bit rich, you know. So I was just thinking, well, surely using like deep learning nonsense, you could just have all the faces animate the person talking what they just typed. And so it'd be like an animated Slack, but it'd be fully automated. You know what I mean? You just upload your little avatar and then it'd just animate you talking whatever you said.
Like
And
motion capture kind of.
yeah, exactly. And just maybe it would make people friendlier, because if you see like just an empty face, you're kind of like more annoyed than maybe if you saw like a friendly person saying something.
Yeah, I like it. What about a little drawer on the bottom of your computer, and if you are nice, it drops candy into there for you.
Yeah.
And if not, it releases a fart.
Yeah. And a technician comes around every so often to refill it.
Yeah. Yeah, can you restock the candy? No need to restock the farts. That's full. I'm afraid we're going to have to check.
It's
It's
part of
part of the service agreement.
yeah. I'm sure something like that'll happen one day, no doubt.
We can only hope.
We can only hope, yeah.
Yeah. All right. So the episode then, I believe, let's see if we can find what this is called,
Yeah, we've got it
is
in
is
advance.
going to be called AO9 We4GAR O93H.
Yeah. I think this is an improvement. I think our names are getting better.
And it's
More.
lucky that this isn't streamed live, because otherwise someone could write that down and then jump into the room with us, the
That's
unsecured
true.
room, and
They
do a
might be able to
drive-by.
yeah.
So that's very lucky.
Yeah, it doesn't help set the agenda very well, though.
No, it does totally, because we're talking about something that happened in 2009, presumably.
Yeah, okay. True.
Um, you know, and something to do with Ghana, I can only assume.
Right, okay. Some kind of Ghana event of 2009.
I shipped beds to Ghana once when I was
Did you?
working at a place when I was a student. We packed a shipping container full of weird furniture stuff and sent it off to Ghana.
To be resold, or was there like one buyer?
Yeah, to be resold.
Did you do it again? Did it
Once
go
only, yeah.
once only, once off? Was that around 2009? Probably.
I would say, yeah, maybe, don't know, maybe a little bit before 2009,
Yeah, okay.
probably like
That's pretty,
2005 or something like that.
that's a pretty good connection. I think you've you've solved it. I don't have anything. I don't have anything like that. Was it weird furniture, or was it just like classic Australian furniture?
Well, it was Australian, but it was also weird. It was Australian waterbed stuff.
Yeah, pretty good.
I don't know if there's a big market for the old waterbeds in Ghana, but
Yeah. Well, evidently not. He didn't.
yeah. Or
He
maybe
didn't
they
get.
found another supplier who could
Yeah, they
meet
could.
their volume requirements.
That's true. That's true. It's possible.
Yeah. Yeah, so I don't know. That's once again, not much planning or agenda has gone into the preparation for this episode. So
Yeah.
I guess we'll just shoot the breeze for a little while.
Yeah.
But yeah, I had a brief look at that quantum paper you sent me, and it's well and truly, I do not understand what is going on there.
Oh no, which one was that?
I think it was this parameter optimization
Oh
molecules thing.
yeah, I think the business is like it's something that I've talked to uh, a colleague of ours about, and he used to get quite upset because there's like two ways people think about quantum machine learning. And one is kind of like imagine if all your machine learning happened like inside the quantum world, like it all happened quantumly. You know,
Yeah,
you never escaped classically.
yeah,
Maybe that's what true quantum machine learning is.
yeah.
But another way to think about quantum machine learning is maybe it's just regular machine learning of parameters that then feed into some quantum simulation or circuit.
Yeah. And
So
it's
that
just like better at gradient descent steps or something.
no, it's well,
No?
maybe it's got like nothing to do with well, so now all the optimization is happening classically,
Yeah.
but maybe you're just optimizing for a different. Maybe there's extra constraints, and one kind of constraint, one thing that you maybe don't want to do very often quantumly is measure your circuit, because kind of the
Hmm.
more times you measure it, you know, maybe the more times you have to reconstruct it and run it again and then measure it again.
Oh, yeah.
So maybe that kind of like wildly increases the number of steps you'd have to run.
Mm.
So maybe there's these kind of like classical optimization algorithms that are good in a quantum setting, and they let you optimize classical parameters of quantum circuits. And in
Mm.
some ways, you can think of that as like that's not quantum machine learning at all. That's just
No.
like machine learning done on quantum stuff. But it turns out that at least at the moment, that kind of machine learning is highly relevant
Mm.
and useful, and the other kind is not. Maybe one could argue doesn't even exist in a like a super practical fashion. So yeah, that's what the kind of that little um, Qiskit, this library from IBM, is kind of introducing is
Yeah, right.
they call it variational quantum. They call it variational because some parameter is varying.
Yeah, yeah. Do you
Um,
reckon that IBM is like using this every day? They've got their quantum cloud and they're using it to do real applications, or do you reckon it's like just research stuff?
I think it reminds me a little bit. Maybe this is harsh, but it reminds me a little bit of like I don't know if you. Well, yeah, I don't think you did. Oh, yeah, you would have done physics in like high school,
No, I
and you
did
know
some physics in engineering as well.
in engineering as well, yeah. But you know how like early on in physics they take you into a lab and they make you like roll a ball down or something, or like fire up a Bunsen burner or something. You do
Mm.
these kind of like really classical experiments just to prove to yourself that hey, the physics that is written down in books, I can kind of experimentally verify that.
Yeah.
And it's kind of it's fun, but it's certainly not necessarily providing like new research insights every time a student does it. You know, it's
Hmm.
just kind of like educational.
Hmm.
And my feeling is like a lot of what goes on the IBM cloud is in that vein. Like there's certainly probably like a lot of learning of like how do quantum things operate and like and so on. I at the moment I couldn't even guess really how much kind of real stuff is done. I
Mm.
do know there's plenty of kind of real research that's done. Like, you know, someone will publish a paper because of some experiment they did on the IBM quantum computer.
Mm.
But my guess is that the majority of it is kind of just like fun, educational learning. You know, hey, this thing that we've long believed is true. Is it? You know, like, can we actually see that happen? You know,
Hmm.
stuff like that.
Hmm. Yeah.
It's just my guess, though.
Because I was imagining like, because IBM's like, they've got Watson or whatever they do for their day-to-day work, and they're like, there's some engineer working on that, and they're like, someone's asking a question about Jeopardy. We've got to download like the Jeopardy
Yeah,
answers um,
yeah,
from 2009. in Ghana,
Yeah,
and
yeah.
and Jeopardy's got their API, and so what I'll do is I'll use curl, and
Yeah.
then their manager hits them and says, "No, bad engineer, you've got to use quantum curl."
Yeah, yeah, mistake. Yeah, yeah.
And they're
That's
like,
how we
"Oh,
built the damn thing.
we're dog fooding here. If you don't use our quantum cloud, then we're
Yeah,
going to look like idiots."
get out of here. We got to be the first adopters. I mean, I hope so.
The engineer is like, "Oh, stop hitting me."
Probably trying to. Yeah,
Uh,
yeah,
I mean, it's obviously just a joke because IBM just has salespeople, don't they?
yeah, true. Well, and advocates, right? Everyone's
Yeah.
got developer advocates.
Mhm.
Yeah, so I was looking into that a little bit. That was kind of fun. I got a bit distracted actually because I was, as you know, I've decided I want to have this website called Between Books,
Mhm.
where I write down thoughts about books that I'm reading, let's say. And I've been kind of totally stuck for progress because I couldn't decide how the website should look. And as I've kind of told you before, it's a real flaw of my personality, if you will. But like until I can work out exactly how something is going to look, I can make no progress. Even though I could write all the content down, I'm writing down all my thoughts on this book right now, and I could have done that before I decided how the website looks. It's just totally impossible for me to make any progress until I'm feeling happy that, like, okay, this is at least a good start.
Yeah.
And so I was getting really, like, I was really annoyed at myself the other day because I was like annoyed that like I can't make these pictures the way that I see them in my head or whatever. And then but luckily, like, I think yesterday I worked out, like, I found this really cool LaTeX font
Mhm.
that I wanted to use. And because Between Books, the two words start with the same letter.
Mhm.
So you can use those super cool scripty fonts
Mhm.
to have like a really cool capital B and then like
Yeah.
do
Right.
and so I made that little logo, and then I made just a really rough website design. And for the last few days and all of today, I've just been kind of finally trying to, because I've just finished this giant book, and I'm finally able to write up my notes of that book, which is great because it means I don't have to carry the damn book around anymore.
Mhm. Mhm.
So I'm really quite excited, actually.
And
It
so
was
you've got a few like sketches about what you want this website to look like now.
I've done it. Like, it's not perfect. Like, one day I'll get a better logo and like clean up the design, but
Yeah.
it's like it's at least good enough to keep going.
Yeah. Yeah.
Like, now I'm kind of happy about it because I bought the domain name,
Mhm.
and then like I was kind of, and you know how it is, like if you leave these projects too long, you just never come back to them.
Yeah.
And so, or at least it takes years. So I kind of just wanted to get it started, put it online.
What's the
So
domain name?
it isn't online yet, but
Oh,
the
okay.
domain name is betweenbooks.com.au.
Right.
I wish I'd had
But
it on.
I could dig it if I needed to look at
You
the
could,
DNS
it'll
record.
need to verify that like I own it. Yeah, you could do that. And who knows, viewers of the future might be able to go to the website now. Um,
Yeah.
so yeah, I'm really, really excited about that because I'm finally like I can make progress. I can write my little, and then I had, because of course a book has lots of metadata associated with it, and then I waste time kind of thinking about such questions as like, oh, how am I going to get this metadata? Like, am I just going to write it out by hand every time? That's crazy. Am I going to sign up for the Goodreads API and make an app? And like, it's like, that's also crazy. Like, and I just want to live life.
Yeah.
So I came up with like a happy middle ground to kind of just live life,
Yeah.
just getting the information that I needed. So it's such a feeling of relief, hey, when you feel like it feels like I've got momentum on the project, which I think once you've got that feeling of momentum, at least for me personally, it's like so much easier.
Mm.
It's kind of like nothing matters anymore. I can just kind of now I can just start typing anywhere in the project and things go nicely. So
Yeah,
I'm
yeah.
really happy about that.
Oh, that's awesome.
Yeah.
Yeah, I've just been trying to squash some bugs and get a new kind of WebSocket subscription thing going. So like I don't know when I talked about this last, but I'd been thinking about how to do some WebSocket subscriptions from Haskell for
Yeah.
GraphQL queries and stuff, and I got it all working. I might have to turn off my Slack because I'm getting work notifications.
Yeah.
I got it all working, and it it's quite good, right? Because now rather than having to poll stuff, you just subscribe and it takes care of it for you, which is like ultimately like not a major change, but it's nice. Because anywhere
Yeah.
where you've got to encode a magic sleep number, you're like, yeah, this is
This is a,
terrible.
yeah.
But it was all kind of hard coded to IO, and that's well and good. But then, like the previous polling version was kind of like in a maybe T monad, and then they're not really compatible, and so that threw me down this rabbit hole of this monad base control stuff and
Yeah.
things like that, which I've seen a couple of times, but I've never really bothered to learn it. I'm just like, that seems like, you know, people just kind of making their own lives too complicated. But
Yeah.
after kind of reading a few introductory posts, I'm like, oh, okay, like, so the sales pitch, the elevator pitch is just like Lyft.io solves all your needs if you've got like an IO that you can work with. But what if you actually need to supply an IO callback? What do you do then? Well,
Right.
Lyft.io is only going to allow you to really kind of like turn something into a different monad, but it won't allow you to like use your monad as an IO callback for something that wants an IO callback.
Right. I see.
So that's kind of what this monad base control, monad trans control, and unlift IO and libraries like that are for. And
Yeah.
so I've been mucking around with that stuff and I got it working, but then like, and so I'm like, oh, brilliant. So now I've got what would have been a kind of polling loop, which then, returns a maybe T kind of request to stop processing if you ask it to shut down or something.
Yeah. Yeah.
And I do the exact same thing in a subscription. Great. But then I'm like, oh, actually, like, it's a bit of a fudged it, right? Because what it is like if you've got a nice polling loop, then guaranteed every 5 seconds or whatever, it's going to evaluate that maybe T action and potentially stop. But if you've got a subscription, well, if there's no data coming down, like
Right.
it's not
Yeah.
going to shut down anytime soon.
Yeah.
So yeah, like even though like the code doesn't have to change at all, and at a high level, like the behavior is identical, like actually, like in terms of the semantics of the thing, well, the timings like changes quite a lot. Um, so that's bad, right?
Yeah.
And so I was like, well,
That is interesting.
I mean, there's various ways you could attack this, and I was like, well, I mean, we use conduit for other things, so I'm like, well, we could do a conduit. And so like this is something I'd looked at actually a long time ago, maybe even like 6 years ago or more, where I was like, oh, I like kind of conduits and stuff because you can make little pipelines.
Yeah.
But what I actually want to do more often than that is kind of like join different things together,
Oh, yeah. I remember you've talked about this thing so many
in
times.
parallel, right? So
Yeah.
it's like, yeah, I mean, I want to, like download the users and then map the users into widgets and then,
Yeah.
display the widgets and then log the outcome and then whatever.
Yeah.
That's my
Yeah.
program, run that.
Yeah.
But also actually like, oh, I want to pull in from the side some statistics, and I want to like pull in from the side some other social media thing, and like it's more like a tree in the simpler case, or like a graph in the complicated case of all of these kind of divergence and convergence of these pipes rather than just a linear pipe. And
Yeah.
so the a while ago I looked into this, and yeah, like I mean, there's it is kind of theoretically possible to do it with the main like coroutines libraries like Conduit and pipes and things like that,
Yeah.
but it's not particularly pleasant, especially if you want to actually do like concurrent convergence and things like that.
Right.
And
Yeah.
like all of the examples I see given are, well, why don't you write out this big kind of manually recursive loop with a giant tree of case matching on all of the particular edge cases?
Yeah.
It's like, I mean, I understand that that kind of has to happen under the hood, but aren't there some combinators for this? And the answer is pretty much
Yeah.
no, right? The only one I found that has some is machines, seems to care about that a little bit,
Yeah.
and has some nice arrow instances. So arrows do that kind of stuff quite well.
Yeah.
But even then, it's like not really built for concurrent kind of convergence. And so everything proceeds in lockstep, which is nice. And you do want that sometimes, but sometimes you don't want that, right? Especially
Yeah.
in this kind of like circuit breaker scenario. It's like, well, actually, I definitely don't want to wait for both values to appear before I can act on them. The whole point is that
Yeah.
I want to circuit break as soon as the circuit breaker is triggered, right?
It's triggered. Yeah, exactly.
So it's like, well, I want two sources. I want my circuit breaker source and I want my value source, and I want to
Yeah.
combine them into a new source of maybe it's an either, and then that's going to like
Yeah.
shut down as soon as
As the left one comes
as
through
soon
or
as the
whatever.
left comes through,
Yeah.
exactly. Or like, you know, maybe something downstream decides to shut down when that happens, right?
Yeah.
Um,
Sounds pretty reasonable. Doesn't sound crazy.
yeah, and I don't know, like maybe I'm just like terminally unlucky at finding these kind of things, but it came up again because like I have this use case, and I'm like, well, what I want to do here is that same old thing, but I'll try a different approach. So this time I'm like, rather than trying to do it natively with the coroutines primitives, which always seems to kind of like be annoying, what I'll do is I'll be like, well, I know I've got IO in the stack somewhere, so I'll just like get these two conduits. I'll just run them both literally in parallel with the async package, and then I'll like
Yeah.
put their results into some kind of channel, and then it's good to go. And that seems all right, and it seemed to work. Like it's a little bit fiddly to make sure you're going to like actually shut down as soon as one of them shuts down, but you can do that without too much problems.
Yeah. Yeah.
Um, and so then like that seems to work, and it's all good, right? And so now I've got a way of like short circuiting with conduits. So then I've got, well, now I want to like turn my subscription into one of these conduits. The short
Yeah.
circuiting
Yeah.
can be
Yeah.
deferred because I've got that. And so it's like, well, actually, because I've got this new monad base control version of my subscription, which allowed me to use the kind of maybe-t thing.
Yeah. Yeah.
Well, now, like, what I would hope is that rather than like it allowing just a maybe-t instance and maybe some other kind of obvious instances, I'm like, well, maybe it'll give me a conduit instance, and then like my problems are over. But it didn't. It
Sad.
just didn't give me one. So I don't know, like whether I have to write an instance or if actually that's quite a difficult thing to do. I think it should be easy enough to do, but we'll see, I guess.
Yeah.
So that's kind of what I'm having a look at now. But it's
Sounds fun. A little bit of a sidetrack off the main task.
yeah, I mean it's a little bit of a kind of yak shaving exercise, but I mean whatever. Like I just want to get it out of the way. But the thing that's annoying to me is actually like, oh, aren't you doing some weird edge case with this kind of weird combining of like circuit breakers and kind of resource T style things and monad base control. It's like, who would think to put these things together? Surely it's like a very niche area. But actually, like, I believe FP Complete is like the author of all three of those things, and they all kind of use each other quite often. So
Yeah,
it's like, but actually, this one use case just, I don't know if everyone reinvents the wheel or like no one ever wants to do this, but it's like, I mean,
yeah,
I would have guessed that there would be an instance, but maybe there can't be for some technical reason.
yeah,
But yeah, the docs aren't great either for this kind of thing. Like, I found the fun thing I found was I'm like, well, what I'm going to do is I'm just going to look at the source for some monad base control instance, and I go to the source and there's nothing there. I'm like, that's very strange. Maybe like Hackage is broken and can't jump to
yeah.
lines or something. But like squinting a little bit, actually, it was a CPP macro
Oh
that
no.
generated all the instances. I'm like, oh God, and there's really no documentation about what's going on
Yeah,
there. So mm,
it does. Yeah, I was just thinking it does. I was just thinking that like you're kind of saying like haven't they written something like this before or something, and it's just I don't know if it makes sense, but it's almost like there could be some middle ground between like open source and closed source, which is kind of like maybe you don't because I was just thinking of a colleague that I'm going to be working with. She and her colleague started this journal of forgotten exactly what it's called, but it's journal of like no results or journal of empty results. It's like you do some research, you don't find a result, and typically you don't publish it. But what
yeah,
if you
I've heard
did?
of that.
Yeah,
That's your
and
colleague, is it? That did
yeah,
that endeavor. That's great.
and so
What is it called?
um,
Like the Null Hypothesis Journal or
yeah,
something like that?
yeah. I wish I could remember. I'll try and look it up, but um, oh yeah, it'll just be on the website, so I'll just look that up. But I was just thinking, like a little bit of a middle ground there would be kind of like a register of like things I've done, and that maybe I could be convinced to like convert to open source or at least tell you how I did it. You know what
Yeah,
I mean? Kind of
yeah,
like gists or something on GitHub, but it's not actually code. You know what I
yeah,
mean? It's just kind of
yeah,
like because I think what's interesting is kind of like that's if you think of just like local communities, that kind of knowledge is knowledge that is easily passed around small groups of people,
yeah,
which is like at a meetup you can learn that this person they probably worked on this, so I could probably just ask them how they did that and maybe they'd even share something with me.
yeah.
But it's like if you're not part of the community, it's actually
Yeah, it's
probably
hard to
impossible
figure
to
it
get that
out
knowledge. Yeah.
for sure. Yeah.
The journal is called the Journal of Unsolved Questions.
Oh, that's cool.
JUNQ.info.
Junk.
Junk.
Oh, that's great.
Um,
Yeah, I
but
love it because like yeah, like I mean it's a massive kind of like selection bias problem for any meta studies, right?
yeah,
Because
totally.
you don't hear about any of the stuff that people just didn't get the result they were looking for.
Well, and it's also just like such a huge barrier to any field because I think when you kind of well, I know me myself when I kind of go down those paths, not that I do real research, but it's like when you just go down that kind of line of thinking and you think for ages, like a week or whatever, and then you talk to someone and they're like, "Oh yeah, no, it's well known that you can't do that." You're kind of like, "Is it well known? Like I didn't know it. How was I supposed to know?" And it's like the only way you could know is being by being part of the club, you know. And it's like, well,
True,
no, almost
true,
no one starts their life being part of the club. You've got to like get get in somehow. You know what I mean? It just
totally.
seems like
Yeah,
an annoying barrier.
it's really annoying. Yeah, kind of like I don't know, discoverability, right?
Yeah.
The other thing I was thinking about, kind of related to that, is wouldn't it be cool if there was like a way to comment on anything on the internet.
Yeah.
And it's like it's it comes up like in line with whatever you're looking at, and anyone in the
Yeah.
world can kind of comment on that. You don't have to go off to a separate thing to comment or whatever, right?
Yeah.
And it's not like Reddit or something, where there's sub communities or anything like that. It's just like it's kind of baked in to the URL or something, right? It's like
Yeah.
your
Yeah. Yeah.
browser has the main content and then the comments.
Yeah. Yeah.
I don't know if
I do.
that's like a good idea or a horrifying
Oh,
idea, but
sure, it's a terrible idea. But I do remember something like that. I remember back in the early days of browsing web pages, there was definitely tools for kind of taking little notes and stuff like that. I'm almost certain with some of these research tools like Zotero or something, you can take notes. I think it would be kind of I know there's some like can't you can see people's comments on certain websites, and I have to say they almost always annoy me.
yeah.
Like I almost never ever want to see it.
But those
But
comments are under the control of
the
the
website,
website,
yeah, I
right?
see, I see, I
Terrible.
see. Yeah, huge mistake. You want
Um,
them
on the blockchain.
universally, universally, yeah, on the blockchain. But surely we'd be allowed to comment on blockchain blocks themselves as well. So
If they've got a URL, of
if
course.
yeah, yeah,
But I mean, yeah, no, like obviously you can do that.
yeah, yeah,
I don't
yeah.
know, like there's some kind of trickiness because URLs are a bit weird, and
Yeah,
is there a canonical like kind of you know method for
yeah,
determining
yeah.
what something is? Who cares?
Who
Doesn't matter.
cares? Yeah, yeah. Well, don't they say like every, you know, like every? It's probably not true from a physics point of view,
Mm,
but like, you know, every every instant of time is like unique or something. So it's like doesn't as long as you take the URL and the exact time and other stuff. You know what I
mm.
mean? I don't quite know what I'm trying to say, but yeah, it's not a bad idea. But
Certainly,
I was
it's one of those things where it's like probably just a net negative for the world, but
I
probably
would
would be
imagine,
quite popular. So
I would imagine
gotta
so.
like put some ads on there and make some money.
Yeah, yeah. It doesn't bode well though for like the increasing, you know, ability to communicate. It's like, well,
No,
if we could talk about absolutely anything all the time with everyone, would that be a good idea? Definitely not.
yeah, yeah.
I
You
don't know.
have to go to your like local news um, stations comments to know that actually I don't care to participate
Yeah.
in any dialogue with most people.
Well, one of the stupidest thoughts that I had for many years is like it's kind of related to this, but it's like how the Buddhists, and full disclosure to everyone, is like I would probably call myself a Buddhist, but
Mm,
you know how the Buddhists they like to talk about um, everything being connected, and
mhm.
like all things are one. And I often wonder, like, well, there's these famous Buddhist authors,
Yeah,
right? But could I write a blog post and just pretend to be one of these authors? And then when they get annoyed, I'd just be like, but we're, everything's all connected. You know what I mean? Like,
I'm
it's a,
pretty
it's a,
sure Buddhists aren't allowed to get annoyed anyway.
it's
So
probably, yeah, it's probably in the constitution when you sign up, when you sign the form.
uh,
But you know what I mean? Like that
yeah,
argue, like that kind of argue, like, oh well, aren't it's like there really is only one person anyway, so it kind of doesn't matter if we could all hear everything we're all saying. It would kind of be probably good.
yeah.
You know, I don't know.
It's a real gotcha for those, Buddhist detractors.
That's true. Can't fight it.
So are you still interested in the Haskell meetup at the end of the month, next couple of
Yeah,
weeks
yeah,
away?
yeah. I'm absolutely. I just learned something from the Haskell channel, the what is it called, the Clash channel, because I
Yeah.
was trying to understand. I mean, maybe I just learned something. I was trying to understand. So the talk that I want to give is something I came up with what I believe is the world's worst talk title that's ever
Oh,
been
okay. Yeah.
constructed. Um, I've forgotten what it is. FBG going away party
Oh, yeah. Yeah.
clashing, something like that. But
Yeah.
the point is that FPGAs have a clock
Yeah.
which runs your program every step clock
Yeah.
cycle.
Yeah.
And then I thought, but then all the devices that you attach are kind of like, we only want to run at this speed. And that's
Crazy.
like so annoying. It's like, why can't I just send you commands at whatever whatever speed I'm sending them? Why
Yeah.
do you
If you
have
don't like them, then you
if you
don't
don't
have
like
to.
it? Why don't you manage it? It sounds like your
Yeah.
problem, not my problem.
That's right.
But they say to me, well, it's just the way we were built. So the point is, I thought you could kind of just define a new clock kind of magically in code.
Yeah. Why not?
And there seemed to be some code in Clash to do with that. But I think the point is, I don't think it's that easy.
Hmm.
I think if you do want to do something on a different timing schedule, you've kind of, well, I
You got to
mean,
do
maybe
the
one,
maths.
you got to do the maths, I think, and maybe one could abstract that out at a high enough level if they wanted to, but I don't believe that level exists in Clash at the very least.
Is there
Is it?
some? Is there some like then like divisibility implications to
I
that?
think so.
Or it's like, well,
Look,
if you've got two schedules, they've got to have like common divisor or something like that.
I think there is, and the blog post that I was following, it's the base clock speed they had was something like 12 gigahertz or whatever the scale was,
Mm-hmm.
and mine is like 16. And
Mm-hmm.
they were talking through how they kind of activated the LEDs, but it all just worked out perfectly because 12 was, whatever number they needed was divided perfectly into 12.
Mm-hmm.
And I was like, well, that doesn't quite work for me.
Mm-hmm.
So I think this is what I've seen a few people kind of say about the FPGA world, is that it's just like quite um, frustrating because there's really like less of that. Like at least if you put up a repository on GitHub to do with Haskell, you know, I mean, the landscape now is changing a little bit, but like I'm fairly sure I can run it on my computer.
Mm-hmm.
Like it at least takes me like 10 minutes to figure out how. Like it's not impossible.
Mm-hmm.
But I think with some of this FPGA stuff, you can't just like clone something and run it
Mm-hmm.
because it depends really strongly on the exact piece of hardware you have. And
Mm-hmm.
it's like, well, sure, if I go and buy all the exact pieces you have,
Mm-hmm.
then probably I can run your exact program. But if I
That
want to
sounds
just
annoying.
change it,
Yeah.
yeah. So I
Yeah. It's
think
like
there are some things to kind of get around this, but frankly, I'm just not familiar enough with the world to know about it yet. But
right. Right.
nevertheless, maybe, well, I'm gonna at least, yeah, once I've done my little between books website, that's my next thing to get back onto the Clash stuff and try and do
That's
this
going to be
final little
awesome. Yeah.
project. Yeah, I'm pretty excited about it actually. It's nice. I have to say, it's nice to make the most use of this time that I've got now, roughly between jobs, to kind of try and do a bit of this stuff. Sometimes it's easy to get frustrated at like not having anything to do, but then at least right now I'm kind of entertaining myself pretty well. So not a terrible problem to have.
Mm-hmm.
Yeah.
Mm.
Have you
Yeah.
got any other fun stuff you're going to look into or have been doing?
Well, yeah. Let me think. I guess. I think like the one thing I've got to have a go at is like finding a good solution to this kind of Haskell zombie threads problem, where it's like if you're kind of depending on something that's not disciplined about how it cleans up its threads that it's spawned, there's really nothing you can do. Um,
Hmm.
Oops, I've just pinned myself. How do I pin you? There we go. Yeah, so well, nothing that I know of that you can do, right? So it's like you can go fix their library that you depend on is really the only option that I know of. But worse than
Yeah.
that, you're not even able to be aware of the problem until like it has some effects on what you're trying to do, right?
Yeah.
So it's
Yeah.
like,
Yeah.
yeah, and until you've noticed that your database kind of connections are exhausted, and then
Yeah.
you go, why is that? Like you really would have no idea, or like your RAM keeps going up or something along those
Yeah.
lines. Um, and so I'm thinking, well, there's surely actually got to be a way to check the reference graph or something like that,
Yeah.
and be like, and identify these things at least, and be like, you've got a leak and it's coming from here, kind of thing.
Yeah. Yeah.
That'd be handy and useful for a lot of people, I think. And maybe that already exists, but at least I'm going to have a look into that. And if it does
That sounds
exist,
real
then
cool.
happy days. But if it doesn't exist, then maybe I'll see if it's possible to create it. But
So kind of doing some like runtime instrumentation of Haskell programs, or
yeah, exactly. Yeah, like a lot of people I've talked to about this are like, well, like, can't we just do it kind of like how Erlang does it? Because they don't have this problem. Um, and unfortunately, I don't think that's the case because Erlang really kind of like right from the get-go with their OTP and process supervisors and gen servers and stuff like that really thought about this kind of issue of how to let things die and how to clean up,
right?
and so they've got a great ecosystem, and they can very easily kind of like make sure things clean up, and even more easily monitor kind of what's going on. But Haskell, I think, you know, hasn't traditionally cared about that kind of thing that much. So
Yeah.
it's ironic because it's like if you're doing kind of normal Haskell code, you're in a great spot and everything's very safe and you've got a lot of kind of tool assistance.
Yeah.
But as soon as you're like, well, I want to just kind of like spin off tons of background threads and kind of do a bunch of, like imperative threaded programming style stuff, like all the help and guarantees go out the window, and exceptions are another big piece of the problem where it's like
Yeah.
there's no real kind of way to check that you've covered the kind of exceptions you want to cover, and you don't want to catch all exceptions because then you might actually catch something that you don't want to catch,
Yeah.
and like all of these things interact heavily to make it to arrive at this situation, which is why you used Haskell to avoid it in the first place, which is it slows you down, right? And
Yeah.
you lose confidence, and you can't just kind of develop and let your type checker check that you've done it right. Instead, you're
Yeah.
like, oh, well, did I kind of consider all these kind of like zombie kind of scenarios, and did I actually kind of like survey the libraries to check that the kinds of exceptions I want to catch are the only ones that I'm catching? And it's a real pain.
Yeah.
I think there's definitely some room for kind of tooling improvements there. But also, yeah, it's like if it was a brand new language, you could kind of think about it and be like, oh, we'll have this new construct to
We'll
deal
add
with
this
that.
or that. Yeah. Yeah. Yeah.
But because there's so much legacy, actually, it's very difficult to just be like, well, we're going to have checked exceptions. You can't do that. It's like there's tons of unchecked ones out there, so you've got to deal
Yeah.
with it.
Yeah. Yeah. I was just thinking of something while I was reminded earlier today. I was trying to do, or yesterday, I was trying to do like very annoying website scraping, which is always really annoying and just so frustrating and
What did you
not
go with
satisfying.
in the end? Did you use HXT or something else?
Oh no, I didn't. Honestly, I didn't even bother to use Haskell because my last
Oh yeah,
experience using Haskell was too annoying, and I was just like, I don't, I'm not, wasn't in the Haskell ecosystem necessarily, so I was like,
yeah.
I just want to live my life.
Use Python or
So
something.
yeah, I used Python, and I tried to use this one called Autoscraper,
Yeah,
which looked very promising. Which was kind of like you just provide it a URL and an example of the
Mm-hmm.
data you want to retrieve,
Mm-hmm.
and then it should learn how to retrieve that data. And I tried to use it, and of course, it didn't work very well.
Mm-hmm.
And so I was like, okay, that's lame. But I think the idea itself is great. And I was just thinking it would be really cool, not only in the web scraping world, but even in that world that you were just describing, is like if you could kind of do this like different, you kind of like have these two things and you run them twice and they produce different output. And then like you get a diff. And then you kind of use this like super cool tool, whatever it's called, like super learn diff, super learn difference pro thingy. And what it does is you basically say like, hey, this difference that I just computed, this is what I care about.
Mm-hmm.
And then you could just run more, run your program more times. And the more you run it and the more you help refine its kind of guessing procedure, the more it would be able to come up with like a really nice simple rule for how to extract that value. Like in your, like, let's just really simplifying what you want to do is like, imagine if somewhere in the memory of the programs that you could dump out, it just had a thread count number that was just going up.
Mm-hmm.
And then you could like coax this program to like watch that region of
Mm-hmm.
memory as you do like many, many runs.
Mm-hmm.
And the cool thing would be that you could teach it to do that by example rather than by explicit programming.
Totally. Yeah,
And
that'd be
then that
good.
might be really cool because maybe you could do like all kinds of things with it. You could like solve that stupid web scraping problem and who knows what else. But it's like that feels like a cool AI tool that would actually, if you could do it right, could be really, really useful, which is
Mm-hmm.
like a kind of like it needs a name, but you know what I mean? Like this kind of differency engine thing that like looks at differences, but then lets you narrow down like, hey, I care about this, 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 and
Mm-hmm.
then lets you like refine that.
Yeah, I mean, it sounds awesome. Microsoft Visual Interactive Difference Pro,
Yeah, I think
2009 Garner edition.
yeah, I think that's a simple and intuitive name.
All right. Should we wrap up?
Yeah, I think that's good place to end.
All right. Thanks, Noon. I
All right.
will